We're starting a new chapter now, Chapter 3, Functions and their Graphs. In 3.1, we're going to discuss what functions are, and we start with the definition of a relation. A relation is a correspondence between two sets. A correspondence between two sets. So that's very general. Just as long as we have a correspondence between two sets, we have a relation. If X and Y are two elements in these sets, and if a relation exists between X and Y, we say that X corresponds to Y, or that Y depends on X. And we write X with an arrow to the Y, because X is our independent variable. Y depends on X, okay? So Y is the dependent variable. So given some X, what would Y be? It's kind of the question. So there are four ways to express relations between two sets. One way would be ordered pairs. So for example, if I had -2, 3, and like this is my set, and maybe another ordered pair, 1, 5. I'll just put 2 in there. Okay, so this is a set of ordered pairs, and it tells me that when X is -2, the corresponding Y has to be 3. When X is 1, the corresponding Y has to be 5. Y depends on what X is. So that's one way I can express a relation between two sets, X's and Y's. Another way would be to write an equation. That could do it. I could have what? Y equals 2x minus 1, right? And that would tell me when I put in a certain X, a particular Y, the Y I get depends on what I put in for X. The X corresponds to a certain Y. That will define all the ordered pairs in that relationship between those two sets, X and Y. So a third way would be a graph. So we could graph this line. That's a line, right, with a slope of 2 and a y-intercept of -1. I could graph that, and then you could see what is Y when X is 0? What is Y when X is 10? You could see that relation between the two sets. And the fourth method is something called mapping. You may not have seen that before, but it actually, we're going right into it. It kind of looks like this, where we literally draw a map from X's to Y that show this X leads to this Y, etc. This Y depends on this X. So mapping, you may want to note, kind of looks like this. You could do it lots of different ways, but that's the idea. It's literally drawing a map. Okay. In our definition, we want to let X and Y be two non-empty sets. A function from X to Y is a relation that associates. So now we're talking about a function, right? A function is a relation. It's a relation. So the relation is the big umbrella. And then there's a special group under relations called functions. And it's a relation that associates with each element of X exactly one element of Y. Exactly one element of Y. So that's doesn't have to be true for it to be a relation, but if you want to narrow it down to a relation that's also a function, now you have this restriction. Each X only gets paired with one element of Y. So in this map, for example, we see this X mapping over here to this Y. We see this X mapping to this Y, and this X, it maps to the same Y, but does it meet this requirement? Is each X paired or mapped to only one Y? It is. Does it say that they can't be different Ys? No, it just says that X only gets one Y. So we don't see an X going to this Y and the same X going to another Y. that would not be a function. But each x, there's just one line leaving each x, so each x is only being paired with one element of y. It's not vice versa. This is the only way it goes. So in other words, for a function, no input, so x is our input and y is our output. Remember, independent, dependent, y depends on x, the output depends on the input. For no input has more than one output. So if you put in x as 2, you can't get two different answers. You can only get one. The domain of a function is the set of all x. So all of your x's make up the domain, and the range is the set of all y. I'll put values, I guess. Okay, so that's our domain and range. They've labeled them here. The domain is the set of all the x's. The range is the set of all the y's. Okay, can an element in the range be repeated in a function? See, that's what we're seeing here. That same y is being repeated. Is that okay? Well, I've already indicated that it is. And they're saying, for example, can the points 2, 4, and 3, 4, can that be a function? That'd be like if this was 2 and that's 3, and they both pair up with a y value of 4, is that okay? Can the function contain that? Yes, because what's required? This is what's required. Each x is associated with exactly one y. It doesn't say it has to be unique to that x. It just means that you see 2 matched with 4, but you do not see 2 matched with anything else. 2 only goes to 4. 3 can go to 4 also, but 3 cannot be matched with anything else. Each x is associated with exactly one